Okay, welcome. So, game plan for this video is just to go over the 3 questions that we went over yesterday in lesson 29. So the first question is in your packet. It's example 2, right? It looks like this: square root of x plus square root of x plus 3. And the other 2 questions are your homework 7, which are this question and this question. Okay, so we'll go over all 3 of those questions in this one video. So let's look at this. Now, one thing you have to notice that this question is a little bit different than some of the other questions is that here there are 2 radicals. Oh, whoops. Here there are 2 radicals. In some of your other questions, you only had 1 radical. But what's the game plan here? Can you isolate? Is there a way to get rid of all the radicals in one move? No, you can't do that. The strategy here is you're going to want to subtract either square root of x on both sides or subtract square root of x plus 3 on both sides. It doesn't matter which way you go. I'll show you here with minus square root of x on both sides. And now here, what happens here? We have square root of x minus square root of x. This is 0. And you bring down the square root of x plus 3, and that's equal to 3 minus square root of x. Okay, so now from here, what can we do? The way we can get rid of one of the radicals is by squaring both sides. Okay, and once we square this side, you see the square root of x plus 3 squared, this gets rid of the radical, and it just becomes whatever's on the inside. So it's just x plus 3. But here, we got to put in some work to solve this. Because if you think that this is equal to 9 minus x or something, you just square this, absolutely not. The way you solve this is by doing the FOIL. You have to say that this is equal to 3 minus square root of x times 3 minus square root of x, and you have to FOIL it. It is literally this times itself twice. So you have to FOIL this. And if you think, oh, I'm not used to foiling with a radical, well, it's okay. You can get used to it. Here, once you see it once, you'll get a good feel for it. So here, what's the first move when you FOIL? It's 3 times 3 is 9. 3 times minus square root of x. Okay, so this is where people get thrown off. If I say what is 3 times negative square root of x, that is just 3 times, this is negative 3 square root of x. That's all it is. When you multiply this times this, it just becomes that. And the same thing happens here. This will just be minus 3 root x. Okay? Now here, minus square root of x times minus square root of x, minus times minus is positive, and it's just square root of x times square root of x. That's just equal to x. So this is just x. Okay? But then we can combine everything here. Okay, so look, this expanded to this. But this, we can simplify a little more. We could have x plus 3 is equal to 9 minus, if I say what is 3 root x minus 3 root x, that is equal to 6 root x. Negative 6 root x, okay? Plus x. All right. Now here, what's the strategy here? Before, sometimes we wanted 0 on one side. But here, the strategy, well, not to get 0 on one side, but get radical solo. Get radical solo. And if you're confused on why this is the correct strategy, raise your hand and I will explain it to you. Okay? Now here, let's just get this radical by itself. And the way you could do that is you do minus x on both sides. So now you have 3 is equal to 9 minus 6 root x. Because these you just get rid of the x's, because they each have an x, so you just get rid of them. Now here, let's get this by itself. It's minus 9 minus 9. Now here, this is negative 6 is equal to, this is 0, negative 6 square root of x. And to solve this from here, just to get this by itself, you just divide both sides by minus 6. This becomes 1, right? And this becomes square root of x. But how can you get this by itself? You just square both sides. And 1 is equal to x or x is equal to 1. And that's it. All right. But, well, I mean, that's it for this part of the problem. But remember, we always have to do what? Always check for extraneous solutions. How do you know that this x equals 1? How do you know through this whole transformation that x equals 1, maybe it won't work in the original? So let's check. So if the original is square root of x plus square root of x plus 3 equals 3, now to check it, you just say x is equal to 1. Square root of 1 plus square root of 1 plus 3 is equal to 3. Right? We're just plugging, wherever we see the x, we plug in the 1. Now you check it. Square root of 1 is 1, plus square root of 1 plus 3 is 4, is equal to 3. 1 plus 2 equals 3. 3 equals 3. And it works. So x equals to 1 is a solution. Is a solution. Okay? Good. Okay. Next question. Now let's look here. The idea is very similar. What I want you to do is try and the same strategy here. You see here we have two radicals on one side of the equation. You see this is the equation. There's a left side and there's a right side. They're both on the same side. Here we had two radicals on the same side. What did we do? We got rid of one of them by subtracting it to the other side. Here, that's the same strategy. Get one of these on the other side, then square both sides. Okay? This problem here, you already have, here you have two radicals on the same side. Here you already have one radical by itself. So the first move is just square both sides. Okay? What I'd like you to do is try and do these two questions by yourself. Struggle through it. Don't give up. Okay? I know these questions are not easy. They take time. You see, like, just one question, you see all the work we did? So put in the work. All right? So let's see if you want to see the solution now. Let's see. Let us subtract square root of x minus 3 on both sides. Okay? And now what do we get? Here, this becomes 0. So square root of x plus 5 is equal to 4 minus square root of x minus 3. Okay? Now here, what do? Here we got one of the radicals solo. So to get rid of that radical, we square both sides. Now this just becomes x plus 5. And this becomes what? We have to, the same thing we did here for this problem, right? The same thing we evaluated 3 minus square root of x squared, we have to do the same thing here. We have to FOIL it. Here we FOILed this, and here we're going to have to do the same thing. So that's equal to 4 minus square root of x minus 3 times 4 minus square root of x minus 3, right? So here, x plus 5 is equal to, when you FOIL this, it will equal 16 minus 8 square root of x minus 3 plus x minus 3. Okay? And if you're confused on how the FOIL worked, raise your hand and I will show you. Right? Here, now what do we want to do? The same idea as before is get another, we have another radical here. So let's get this by itself. Right? So here, we could do minus x, and this becomes, well, let's also skip a step. Here we can do plus 3, right? Because we just want to get rid of, this stuff. So this becomes 0. I mean, this becomes 0. This becomes 8 is equal to 16 minus 8 square root of x minus 3. Now here, what happens here? We want to subtract 16. So this is negative 8 is equal to negative 8 square root of x minus 3. And now here, divide by negative 8. 1 is equal to square root of x minus 3. So now here you square both sides. 1 is equal to x minus 3 plus 3 plus 3, x is equal to 4. Okay, and there we go. But remember, this is not good enough. We need to check. So let's plug in 4 into the original and see if it works. The original is what? The original is square root of, so check. square root of x minus 3 plus square root of x plus 5 equals 4. Plug in this 4. So square root of 4 minus 3 plus square root of 4 plus 5 has to equal 4. 4 minus 3 is 1, so square root of 1 is 1. 4 plus 5 is 9. Square root of 9 is 3. So this is true. Okay, it's true. It works. Now for this question here, let's see what happens. 3 plus square root of x. Remember, you're going to have to... Well, let's see. The right side is straightforward, right? This just cancels. This is just x plus 81. But this, you have to do the same thing. You're going to have to... Oh, oops, sorry. Here, you're going to have to FOIL. You're going to have to FOIL this. And when you FOIL this, this becomes 9 plus 6 root x plus x. Okay? And if you're thinking, Mister, how do you know to do it so fast? Here, when we did this problem, for example, notice that this was equal to 9 minus 6 root x plus x. And the way you have to look at it is, how do you get this 9? Well, it's this squared. How do you get this x? It's this squared. And how do you get the middle? The middle is 2 times this times this. And if you're thinking, Mister, what on earth are you talking about? It has to do with this identity. If I have any x plus y squared, that's equal to x squared plus 2xy plus y squared. So this is the rhythm that you're using. If you're confused with this rhythm, it's okay. Just raise your hand and I will show you. So this becomes this, and the same strategy holds. Get rid of this radical. So now here, let's do minus x, and you want to do minus 9. So 6 square root of x is equal to 72. Divide by 6, square root of x is equal to, what is this equal to? 12, right? And then you square both sides, x is equal to 144, okay? And so x is equal to 144. Now we have to check it. So check. 3, the original is what? 3 plus square root of x is equal to square root of x plus 81. 3 plus square root of 144 is equal to square root of 144 plus 81. Well, let's see. So 3 plus 12 is equal to 144 plus 81 is 225. And this is 15, and the square root of 225 is 15, so this checks. Okay, I know I did this a little fast, alright? But try and catch along, go back, ask questions, raise hands, let me know. Okay, this concludes those 3 questions from lesson 29. I hope you get a better feel of these questions. What you could do to get better at this is do some of these questions in the back. Right? These were some of the homework questions. 1, 2, 3, 4, 5, 6, 7, 8. Try and do some of these questions right now, and that's it for this lesson. Right? And then hand it in and I can check your work. Okie dokie. Enjoy.